Welcome, and thank you again for joining me today as we highlight some of the exciting new work published in the June 1st issue of AJP-Heart and Circulatory Physiology, or from the editor's desk. In this issue, we published 13 original articles, one editorial focus piece, and one perspectives piece. So let's take a look at a sample. In our editorial focus article, Hutchinson et al. Show the involvement of miR-21 in impaired coronary collateral growth in the metabolic syndrome and the involvement of apoptosis. Rats with metabolic syndrome and normal rats were subjected to multiple transient coronary occlusions, while apoptotic markers were measured along with miR-21. Anti- and pro-apoptotic proteins such as BCL2 and BAX increased 6 and 9 days after reperfusion injury. Neutrophils increased at day 3. Importantly, anti-miR-21 induced neutrophil apoptosis and decreased BCL2, and improved collateral coronary growth. The authors conclude that neutrophil apoptosis is integral to normal coronary collateral growth, and that the inappropriate prolonged miR-21-mediated survival of neutrophils plays a major role in impaired coronary collateral growth. In a study by Shibasaki et al., the mechanism for changes in cardiac function during heat stress were investigated. The authors hypothesized that cardiac sympathetic activation is required to increase systolic function during heat stress in humans. These studies were carried out in normals, paraplegics, and tetraplegics. While heat stress increased cardiac output in all subjects, the magnitude was suppressed in tetraplegics relative to normal. Diastolic function was maintained in all groups. The data suggest that sympathetic innervation is required to achieve normal increases in cardiac systolic function during heat stress, but not required to maintain diastolic function. Elevated systolic function during heat stress occurs as a result of increases in core temperature, but not skin temperature thermoreceptors. Prisco et al. Focused on the process by which activated endothelial progenitor cells bind to their target tissues. They specifically investigated the TNF-alpha-regulated VCAM1-VLA4 interaction. Using a novel parallel plate flow chamber, a detachment assay, and mathematical model were used to analyze this new assay. Bound cells were subjected to laminar flow, and the cellular adherence was quantified as a function of shear stress. TNF-alpha treatment of endothelial cells increased adhesion through bond upregulation, whereas TNF-alpha treatment of endothelial progenitor cells increased adhesion by increasing bond affinity. These data suggest that injured tissue could potentially increase recruitment of endothelial progenitor cells for tissue regeneration by the secretion of TNF-alpha. Finally, Kang et al. Examined the heme oxygenase system in a murine model of pathological shear stress induced by partial carotid artery ligation. Within minutes of occlusion, NF-kappa B was activated. Following ligation, comparable induction of heme oxygenase 2 occurred in HO1 wild type and HO1 knockout mice. However, HO1 induction was exaggerated in HO2 knockout mice. Upregulation of HO1 augmented carotid blood flow in both ligated and contralateral carotids. Inhibition of heme oxygenase decreased flow in the ligated artery. The authors conclude that the study demonstrates that upregulation and vasoprotective effects of HO1 and HO2 in this model of pathological shear stress. Thank you for joining me again on this overview of the June 1st issue. Just a reminder to those of you who are submitting papers to the journal, we now have a new section called New and Noteworthy that comes right after the abstract. Please don't forget to include this 50-word statement in the manuscript and the metadata file online. We'll see you in 2 weeks and await to receive your best work.